We're going to go ahead and get started. So just to kind of get a feel of the audience, this presentation is very kind of refining chemical focused in terms of the equipment type, like fired heaters, steam traps, heat exchangers. So just want to make sure kind of relevant, or if that ties into your spaces of asset or equipment in your plant. Our guests are y'all for refining chemical companies? Maybe that's kind of an easier question. Yes, no. Okay, I forewarned. Okay, so it might not be as relevant. That's all. That's why I was just trying to say, in case we have some more upstream or midstream, this may not be as relevant. Yeah, that's what I was trying to get at. Sorry. You're welcome to stay, but I can understand. So this is kind of more downstream, I would say, focused in terms of the value chain. So do want to be, I guess, transparent up front for that. Okay. Y'all are like debating to stay or not. Okay. So kind of mentioned this is kind of, we'll talk about it. So the EPA has put together, have y'all ever heard of the Energy Star program? Or do y'all have facilities that participate in that? We'll talk about it a little bit more. But the EPA has a couple different reports that they, depending on industry, they put out, which it has recommendations for reducing greenhouse gas emissions, as well as for improving energy efficiency. So we're going to talk through some of the reports and some of those recommendations around certain equipment types, or the most common equipment type. In particular, this presentation is focused heavily kind of on the refining side, but a lot of it parallels to chemical, petrochemical overlap in terms of equipment type. And so I come from Emerson, which is kind of, we do instrumentation and controls. So I'm part of our measurement division, where flow, temperature, pressure, level, analytical equipment that goes around a lot of these operating units. And so my kind of perspective is looking at how you can use automation or instrumentation to like implement, like to reduce emissions or improve energy efficiency. So how many of you, I guess, are tied to oil and gas, traditional or petroleum-based fossil fuel industries? Okay, so I guess you guys probably hear a lot about the energy transition, decarbonization. I'm assuming there's a lot of sensitivity around it, right, with customers or with your own employees. So I always like to throw this slide up first. This comes from AFPM, the American Fuels and Petrochemical Manufacturers Association. And I always think that is really interesting to kind of myth bust or get people grounded on. But basically, you know, we hear all this talk about renewables and how everyone is kind of thinking of transitioning. But what I think is important, people kind of act like we're changing the whole ocean, but you know, still as of 2050, the EIA, the US EIA estimates still that 77% of our energy supply will still come from fossil fuels. So it's only about a 3% drop up until 2050. And then you can see the equivalence of petroleum-based fuels and how much it kind of equates or compares to other sources of why we still need fossil fuels. So I always like to kind of ground, and my whole point in being that, you know, although there are these new investments, whether that's around like green hydrogen or talks about it, or renewable energy or green diesel production, there still is very much a need and a focus of what are our brownfield facilities, right? And our traditional refining chemical plants, petrochemical, in a sense of improving the emissions reductions there. So in the US, this data all comes from the EPA. This kind of shows like the overview of the landscape of greenhouse gas emissions and what it breaks out to, as well as the top 3 sectors for greenhouse gas emissions. So this is just kind of data that, you know, my sort of argument, because I focus a lot on refining, of, you know, why focus in on refineries in particular. But all of these sort of data, the EPA has a website where you can search. You can actually look at specific facilities and sites within a certain region or territory to kind of see the emissions profile. So, you know, why all of the sudden sort of, you know, scope of work around this, right? With the Biden administration announcing a lot, especially with methane emissions reductions. Obviously, in the US, it's different than like in Europe in terms of we're not taxed on CO2 like Europe is. So there's not necessarily a financial penalty in place by the government, right? There's sort of these sort of mandates and kind of encouragement, I would say, unlike Europe, where there is actually just last year, the CO2 tax for Europe more than doubled of that sort of penalty. So the far chart shows the different tiers of greenhouse gas emissions. Really, I would say the scope of this presentation is around really scope 1, in particular around the process, the actual manufacturing side, and in particular focused heavily on refining, but as I said, the equipment does transfer across. And then as far as the far right, you can see all these sort of different, you're starting to hear some of these terms like circular economy, renewable power, oil to chemicals, renewable feedstock, carbon capture, methane reduction, NOx, right? So very much around what the solutions are in terms of greenhouse gas emissions reductions. I've boxed in where we're going to really focus, which is process and energy efficiency, which is honestly where the bulk of the opportunity is, because this is with our existing facilities, right? And how do we better reduce these emissions? So I talk a lot to refineries, and, we often, I would say coming from a refining standpoint, especially from this conference, recently, about 2 years ago, they had the refinery sector rule. I don't know if any of y'all were familiar with that, with the flare monitoring requirements, and the same transferred over to the petrochemical side with ethylene. But basically, the whole point I want to illustrate is that for a lot of these industries, sustainability has been an ongoing focus. So you can see some of the statistics here that while economic activity in the US has increased, the carbon intensity for refineries in the US has dropped 12% from 2010 to 2018. So there has been quite significant investment in this space and ongoing, especially for the refining side. They have a lot of clean fuels, low sulfur regulations for fuel requirements. So there has been a focus. I would say in the last year, we're starting to see more companies put public goals out there for ESG, executives being incentivized it, investor relations pressures coming around this, as well as governments starting to incentivize or potentially incentivize things like green diesel production, for example, and the credits there. So I would say these kind of, whether it's a refinery or a chemical plant or petchem, most of these are your typical types of pathways or solutions to basically, your pathways or solutions to basically try to reduce your emissions or improve your energy efficiency. So things like advanced process control from the instrumentation side, whether that's improving accuracy or reliability of measurement, and then putting in advanced control over your typical, like layering that on your control system. Wireless technologies is sort of a new one. This is more in the space of reliability. So wireless technologies have the ability to add measurements easier where you maybe traditionally didn't have it in the past. So it's like wireless temperature, pressure, and flow, and they typically go around maybe a compressor, a heat exchanger. So that's kind of a new trend of people adding that layer of data in to better understand equipment. Real-time data series analytics for equipment monitoring. So I would say there's a lot on the floor that I've seen around this space, whether that's for like emissions. So like Wood Group, what you have is falls under this category. There's also a category around for equipment monitoring. So just like heat exchanger performance or predictive or machine learning, if you've heard those terms. Predictive emissions monitoring. I know that I think we have a presentation. I don't know if it already happened. It's in this room or it happens this afternoon around this. So some of y'all are probably familiar with, for your stack monitoring, using SEM analyzers, but there's also the ability to use software to predict what the emissions will look like. So Emerson has that. This one, we have a demo in our booth. So for fugitive emissions, so like pressure relief valves, thinking of those in your plants. There is, instead of, most people tend to rely on manual inspection, or if they can look at the DCS and try to look at and see if there was an incident, how long did it occur, trying to trace process data. But there's actually the ability with wireless acoustic technology to detect leaking valves. And so we've seen that, especially with the refinery sector rule, with valves going straight to atmosphere or ones to flare, that people are starting to add that sort of capability to be able to detect and identify those critical PRVs. We actually have a demo unit that shows you how it works and what it timestamps for the valves. Water management is a big one. So hydrogen production. So how many of y'all have maybe hydrogen production at your facility? Steam, methane reforming, all of that. So this would be classified. Y'all have heard the colors of hydrogen, right? Blue, gray, green. So for hydrogen production, most refineries, chemical plants, if they have their own hydrogen unit on site, they fall under the gray category. To make it blue hydrogen, you would add the carbon capture piece. So we're seeing people look into that. I would say for hydrogen, you know, there's a press for demand of people talking about using hydrogen for like cars, right? In Europe, like fueling stations, the demand for hydrogen, as well as in refining. For those of you who have been involved in the industry, you know the increase on sulfur removal, hydro treating, hydro processing, hydrogen demand there. I've been working in the green diesel space where refineries have been adding green diesel production units. Those tend to have more hydrogen consumption, those reactions, than your traditional hydro treaters and hydro crackers. So a lot of refineries are being pushed to the limit on hydrogen production. But hydrogen production is also usually about 6 or 7% of the emissions from a refinery come from the hydrogen production units. Carbon capture and storage, again, something kind of, it's materialized more so in Europe than the US as of right now, but there's been a lot of different major oil and gas companies kind of coming up and talking about it. The addition of conversion of renewable fuels, as well as biofeedstocks on the chemical side. So this is, you know, using things like soybean oil, tallow oil, animal fats to produce petroleum-based fuels or products. So that is one that in the US currently there is, that it is incentivized. And then renewable power sources, as kind of looking at wind, solar, that would be more on the scope 2 side. Most of the other solutions are on scope 1. So what this chart shows, I'm sure y'all are all familiar with this type of process equipment in your plant, regardless of industry. So this in particular, the data that you see on the table in terms of greenhouse gas emissions, energy efficiency, and fugitive emissions, this is for a refinery in particular. This comes from the EPA. The asset quantity and location, that's like our own tribal Emerson knowledge. But basically what this kind of shows you is the equipment types and their typical contribution in a refinery in terms of emissions and efficiency. Again, all coming from the EPA, but I like to show this to kind of illustrate the nice thing about refineries, which you'll kind of see on the next chart, is, you know, all the refineries are configured basically, you know, the same way. In terms of some units they may not have, but in terms of it's the same sort of processing. But what you'll see is there's a lot of consistency on where the targets are for improvement, in the sense of whether you're looking from an energy point of view or an emissions point of view. It's, you know, 60%, we'll see it on the next slide, comes from combustion. So essentially your fired heaters, your boilers. And so if you look at it here from an energy standpoint of your biggest energy consumers, this shows you by process unit, but it also shows you in a sense by application type. So the focus today we'll talk about will be around fired heaters, boilers, heat exchangers, steam traps, which ties to your boilers, your utility systems. Those are kind of the big target areas if you're looking to improve in your facility, and what the EPA recommends in terms of improving efficiency and emissions reduction. This is kind of where that stands. This chart I love. I always love throwing it up with refineries. This gives you what the emissions profile typically looks like for a refinery. So, you know, I focus in on refining. That's why this is heavy refining, as well as we talked about from that first chart that refinery is number 3 on the sector for emissions type in the US. But the EPA puts out this sort of data. If you're curious for your type of industry or plant, the data is available on the website. That it shows both from the energy side and the emissions side. So, you know, this is benchmarking that the EPA has done across looking at a fleet and for all the reporting that they get to them. So I mentioned these reports. So this is the first report, which I'm focused on, which is just the reducing greenhouse gas emissions at refineries. So you can see how the report works. So their consultants looked at these different types of equipment, and what they did was they made recommendations for some of this equipment type. Due to time, I'm only kind of focused on certain like equipment type, but I just kind of wanted to show and illustrate how comprehensive the report is. One of the things that I would say from our point of view is this report was done, you can just Google it and easily find it, it's available. It was done, I think one was done in 2010, one was like 2015. So a lot of what you don't see is there's not a lot of recommendations when it comes to like cloud-based software predictive technologies. Like it's very outdated in terms of it doesn't have like sort of the more modern stuff you're seeing at this conference, but a lot of this stuff still holds true. So kind of what I wanted to show, this is something that I've done at Emerson with kind of our sales force around it, but this table is actually word for word minus the last column from the report that the EPA has. And so this one was particularly around a boiler emissions. So this is kind of the language to give you a feel of the report. So what they've done is they put a greenhouse gas control measure. So it's aspects around this type of equipment and their sort of description and recommendation. They typically cite case studies from other plants or refineries that implemented what their payback was. They'll reference that. So a lot of times they'll indicate if this is something that has been proven in the field or not. One of the things you'll see, there are more recommendations than these four, but what I have put, because I am focused from an automation or instrumentation standpoint, so you don't see, so I didn't pull those because others are more capital intensive investments like reducing flue gas like quality, improved insulation, putting down blow down heat recovery. So there's all these recommendations that it goes in detail. I have pulled what was relevant from an Emerson standpoint. And so some of these are actually kind of simple solutions in a sense that they may be just as simple as choosing a different instrumentation type, right, to improve the control. Or some of them might be a little bit, could be more sophisticated. So one of the ones that I wanted to highlight is on this. So these are some of those different solutions that tie in around. One of the ones that I wanted to kind of focus in on that I had in another session is around steam trap monitoring. So I guess how many of you for your facilities have issues with like leaking steam traps, or how often are y'all inspecting? Do y'all know? Okay, so I had a session this morning and one of the attendees, theirs was once a year, they bring in a third-party company that would inspect their steam traps for them. And he said when they first started, the failure rate was about 25% for steam traps. Normal we see is about 5 to 10% fail every year. It's a very mechanical device. So the thing about steam traps from an HSE standpoint is typically a lot of times if they fail, they're failing where they're leaking. So you're like losing steam. And so that tends to put more duty on your boiler because you're having to generate steam that's getting lost and not distributed to the process, right? And putting more duty on your boilers increases your emissions. So some of the benefits may not be direct in terms of boiler performance, right? But it could be something augmented like your steam distribution system in this case. So one of the ways the EPA recommendation, I'll go back a slide, was kind of improving and maintaining steam traps. And their estimate for the improvement around that was about 1 to 10% of boiler emissions could be reduced if you had a more robust inspection and maintenance of your steam trap systems. And so these are kind of, again, estimates from the EPA around that, what people have implemented. So, EPA's recommendation was very generalized in the sense of maintenance or regular inspection. What we've seen from an Emerson standpoint, you'll see that the bottom square or rectangle there where it says steam trap monitoring. This is an acoustic transmitter, and what it does is it's clamped onto the steam trap, and it can detect like through the acoustics when the trap is leaking, and it also has a temperature reading, so it can detect a temperature change if the trap has failed close and has condensate, so it's cold. So it can detect both acoustic and temperature, and we have kind of a software solution around it where for all the critical traps, it's kind of a dashboard that tells you the health of it. And so this can help with quick identification and failures. We see paybacks typically in like less than 6 months for implementing this. And that's just more so on a like maintenance ROI side and preventing loss of steam. But again, there's also the emissions impact as well. So fired heaters, this data comes from the EPA as well on some statistics. So for fuel gas consumption, like at a refinery, about 60 to 70% is going into your fired heaters. And then I think just like fired heaters, if you remember a couple charts ago for the refinery, it's about 60% of your emissions. So for refinery, you typically have 20 to 40 fired heaters, very intensive on combustion processes. If you're doing ethylene, your ethylene cracker, the heater for that, also kind of an extreme or a very high contributor for energy and emissions. So for fired heater, there's actually a route around the control of it that is very, very tricky. So these were some of just the recommendations that the EPA had around process heaters. So like air preheaters, draft controls, low NOx burners were a kind of a big one that a lot of people had implemented to reduce emissions. I didn't have it on here per se, right? But SEMS is always a given. PEMS, right? We kind of touched on could be an area of improvement around your stack monitoring. But the biggest sort of challenge has always been around the air to fuel control, right, for combustion. And the reason it's such a challenge, this slide's a little busy, but is, I guess, how many of y'all have fired heaters in your facilities? Anybody kind of, or work through them? I see heads nodding. Do you know if you use fuel gas or natural gas for your source for burning? Natural gas, okay. Anyone use fuel gas? So I was gonna say, if you're using natural gas, you should be more so okay on this. But for people that use fuel gas, especially like refineries and petrochemical plants, so fuel gas composition tends to vary on quality way more significantly than natural gas. Natural gas tends to be pretty stable, but fuel gas, because it's made up of off gases coming from different refinery process units, there's a lot of composition variability, and that composition variability impacts the amount of oxygen needed for combustion. So the tendency is to run at an even higher excess air in the case that you have a spike in the energy content of fuel gas. So you have a rich fuel condition is what we call it. In the case of if you have that, it would sometimes trip the heater because you'll run low on your oxygen, right? So it'll hit those safety limits. So the API RP 556 committee, so this is a committee by the American Petroleum Institute. They look at the safety the safe operation of fired heaters. What they did was a study where they looked at like pressure-based control, volume-based control, which was compensated by pressure or temperature. They looked at mass flow and they looked at energy. So what they did was they developed this software, and I'll talk a little bit about it. These are what some of those charts come from. The most common and current way most fired heaters are controlled in industry is using either pressure-based or fuel or volumetric flow on fuel gas flow control. So that is like the current of what most people do. The practice is being rewritten to recommend mass flow, primarily for a safety reason, but there are also the emissions and efficiency benefits. So what you see on the far left chart, I know it's a little small, is these are two example fuel gas compositions from a plant. And what you see is the variability on a mass basis versus a volume basis in terms of the energy content for the gas. So if you look at it on a mass basis, it is significantly less variable, like 3% on the first case versus almost 15% on a volume basis. So when you're controlling on a volume basis, that variability that you see in the control, or I'm sorry, in the composition of the gas in terms of the energy content and the BTU required, there's more variability in what that oxygen needs to be for complete combustion. When you're feeding a mass base, like a certain amount, constant mass base of the fuel gas, there's less variability despite the composition variations of what the stoichiometric error requirements on a mass basis. So this stabilizes the control. So to visually kind of understand maybe more so what I'm saying, if you look at the 3 charts, so the tool outputs about 6 charts. Energy flow, which is more so theoretical in a sense that we have not seen people feed forward BTU control into a fired heater. That would be the ideal, like best case. So that would be like, you would need some sort of like analyzer system that could update, you know, in seconds to be able to profile the fuel gas composition, run the BTU calculations. We have not seen like an analyzer people implement that. We've seen people that maybe will use an analyzer still for the emissions calculations required off of a fired heater and that, but for control purposes, I have not seen anyone implement energy flow control yet. So what you see, what the API committee did was they ran the software where what they did was they took historical fuel gas, they took the design parameters like the heater duty, and the software models, it clusters the data. So it takes all the raw historical fuel gas composition lab data, it clusters it up to 10 clusters where it says, okay, this composition looks similar, we're going to label it as fuel gas 1. This is going to be fuel gas 2, 3, up to 10. So it has 10 clusters, and it does a Monte Carlo simulation where it'll go cluster 2, then it'll jump to 10. So it'll simulate what you see in a plant in terms of the variation in fuel gas quality. And what it does is it plots the control scheme in terms of what your target O2 should be and how much you're deviating from that based on the fuel gas composition. So what you see is on those histograms, those frequency charts, that's the number of times that your oxygen, your target O2 had varied based on what the fuel gas composition would require. So it gives you a band of your operating window to have that safety margin for covering those rich fuel scenarios. So if you look at the chart, you see pressure and volume are much wider than the mass flow. So the mass flow, which is essentially using a Coriolis flow meter to control, has much more stability than some of these traditional like volume and pressure based. So usually what I do, we have a tool that calculates this, like can calculate the net present value. And we have certain probabilities that are industry standards that we put for probability of like tripping the heater, of the heater blowing up, things like that. But usually the HSE person, the emissions person, this tool will kind of tell us what that target O2 needs to be at in the sense of looking at the plots. What they do is if they can drop 0.5% to 1% typically on their target oxygen, they'll know what emissions reduction that is. So there's a triple sort of benefit in terms of there's a cost benefit from less fuel consumption, there's a safety benefit from stabilizing the control scheme, but then there's also the emissions piece, which by site they calculate based on being able to say if we can lower our target oxygen by 0.5 to 1% is usually what I've seen in that realm. So this is kind of, again, you know, little ways to kind of improving some of these. So I touched already a bit on steam traps, like kind of tied to the boiler system. So I won't touch on this that much more since we already kind of touched on it a few slides ago, but these were just some of the same statistics that I kind of said that, you know, the U.S. Department of Energy says about usually, I mean, and steam traps are in every type of plant, every type of industry, right? But beyond refining and chemical, but about typically you'll see 15 to 30% malfunctioning. And that, you know, usually if there's a regular maintenance program, you can get to less than 5%. But several studies suggest that replacement of steam traps is very low, but payback periods can be just within months, right? And so this is mainly focused on the steam trap itself, but as we mentioned, right, the boiler emissions that are tied. So again, 1 to 10% of boiler emissions can be potentially reduced by implementing like whether it's the regular maintenance sort of program, so sooner than once a year, or doing the online acoustic monitoring. So this kind of gives you a better view of what I was talking about. Sorry, I didn't realize that I had put this. I should have moved it up closer in the presentation. But basically, this kind of shows what I was talking about in terms of it takes acoustic, sorry, that shouldn't say levels, but acoustic sound level and temperature readings. This is a clamp-on style. You'll see it in the next photo. And so this is kind of one of the newer ways that people are monitoring steam traps. This actually also applies to pressure relief valves, as I mentioned. So same exact concept, that the acoustics can detect leaking, can help identify the particular trap. You see some of the software screenshots here in terms of this is like under normal operating conditions, but then you'll see like the software can detect, you know, from the measurements when you have like a blow through trap. And so basically that means like the steam is leaking. So it helps you quickly identify and perform maintenance there. Or you can have what's called a cold trap, where it's like where condensate builds. And so either or, you know, there's process impacts, there's HSE impacts in terms of duty on the boiler, process impacts where it comes to quality of steam, there's reliability and maintenance in terms of safety as well with like leaking steam. So all of these are kind of have multiple benefits. This was actually a facility in South Africa, Sasol, who they implemented this. So they kind of did a pilot program where they installed a few steam traps on their critical plants. And you can kind of see their payback and their annual savings in steam costs, as well as because it was wireless, so it doesn't have your traditional wiring, just some of the installations and the maintenance savings. And there was a quote from their instrumentation manager on the energy savings that they had and achieved from this. And so again, quite a bit of benefits from this type of solution. And so I kind of just wanted to also echo, as I mentioned, we have this in the booth, the steam trap monitoring as well as the pressure relief valve monitoring. But kind of my key point is that these reports, you know, I only pulled subsets to kind of just educate and show y'all they're available out there by the EPA. Some are as simple as what I'm trying to point out, where it's instrumentation. Some are maybe more sophisticated in terms of it's maybe a redesign on process or some sort of kind of new installation or insulation or something like that. But, you know, variable pump drives, like different things, right? But there are some simple solutions where instrumentation can actually help in terms of reducing emissions, improving control around some of these critical assets. So that is what I had for my portion. Are there any questions? If you want to see any of this stuff, kind of some of the monitoring that we have around steam traps, pressure relief valves, heat exchangers, same thing, even though they don't tie to emissions, but they try to energy efficiency with fouling, things like that. A lot of these wireless or sort of solutions we have or have on display, we can also generate business cases on around some of those energy KPIs on energy loss savings or things around steam traps or PRVs, the emissions and things like that. So thank you guys.